Hello, this is Algebra 2-2, Unit 12. It's the last of the study guides for the final exam. I highly suggest that on this unit you go back in and study the notes anywhere that these problems aren't making sense, because this unit unfortunately had the least amount of time where it was the last unit, and you really need to understand the logarithms well to go into the next class. Obviously we did a lot more explaining in class, and we did a lot more manipulating with them. Here, this is just an example of the kind of problem you'll have on the test. First problem, it asks about exponential decay. Remember, the requirements for exponential decay is that the b had to be less than 1. So we look at our b value. It's the 1 being raised to the exponent. If it's a negative, then we know that that would be 1 over e to the 6th. Now, if you wonder what e to the 6th is, if you can't remember what e stands for, go to your calculator and go to the e and raise it to the 6th, because you'll be able to tell at that point what it is. And here it is. There's the e right there with ln, right on that little spot. So you turn it on and you get e raised to the 6th, and you would have 403 point blah blah blah. Remember, it's an irrational number, so that's 1 over 403 roughly. So you know e to the 6th brought it to a larger number down here. That means it is less than 1, so that one is definitely a decay. This one, e to the 4th, you can do it. You can do e to the 4th, but just as we saw in the last one, e raised to a power can become a fairly large power pretty quickly. So if it's not placed under the 1 by the negative exponent, it is going to be a growth. Here, 4 squared, that would be 16 to the x. Actually, you would be multiplying that 2 to the x, but this gives you an idea of whether or not that would be greater than 1 or not, and of course that one is as well. And here we have a negative exponent. That's going to cause it to become 1 over 4 to the 3x. Yeah, I shouldn't be bringing those other number exponents in. We should just be looking at the negative, bringing it to the bottom, causing it to be a decay. So 1 and 4 are your decays because they become fractions due to the negative exponents. 1 and 4. Others are out. And you've already marked up here why. Okay, on the next one, real simple problem here, just a lot of little tedious math that you need to make sure you do. You're starting with a principal amount of $2,500. So in each algorithm, you put in $2,500 for the p. And now it says the bank gives you 3 options below. Find your highest yield. So you're looking for your highest. We need to find our other values in here. So we end up with 1 being a constant in the function. R stands for your rate. Make sure to switch it back to a decimal. So it's 0.025. The n is the number of times that it is compounded. Up here, it says compounded quarterly, so that's 4 times a year. So you go 4 there, and then here again the n is 4, and then how many years? 4. So you'll plug that into a calculator and get your answer. If you don't know how to plug it into a calculator, you better be in the tutoring lab. Okay, here we plug in our function, and we have 1 plus r again is our rate, 0.035. Number of times, its interest is compounded monthly. Monthly would be 12 times a year. And again, the 12 up there. And the number of years is 3 times 3. Again, plug that into a calculator. Next one, 2,500, that's our principal. We need to find the E on the calculator. We just did it in the unit 11, or actually in this one. I just showed you where the E is. It's raised to the rate, 0.025, and the time is 3 years. Now, why didn't we have to look at the number of times it was compounded? Remember, this is when interest is compounded continuously. That's when we use PERT. So calculate those out. You should end up with an answer of B. That would be your greatest gain. Greatest gain. If you don't get that, come see me. Okay, on this one, remember when we're solving for the exponents, we get the bases to be the same. So 64 can be written as 4 to the third. And we just bring the x plus 8 there, equals 4 to the 5x. Now that our bases are the same, we can do log 4 on each side to cancel. Don't have room to show that. So we have 5x equals 3 times x plus 8. Let's go ahead and get it solved. You distribute, then you'd balance things out, and you should come out with an answer of D. D as in 12. Okay, next one. All right, sorry, I'm not going to go through the simple math here. I want to shorten this down so that you're not on the YouTube forever looking for it. Okay, the next one, we're given the equation that we're to use. T is the time elapsed in hours, and we see that it goes from 10 a.m. to 2:30 p.m. 2:30, counting backwards to 10. From 10 to 2 is 4 hours, to 2:30 would be 4.5 hours. So all you really need to do is plug this in for time. So you'll go 324 times your E, which is raised to the 0.62 times 4.5. And make sure that you put that in a parenthesis in your calculator. You should come out with D being your answer. Make sure that you do. Okay. Oh, somebody already wrote on this. I apologize. I didn't see that it's on here. We'll see if their work's correct. State the domain and range for this function. Okay, well, first thing we know is that this is the inverse function of 3 to the x minus 2 equals, 3 to the y x minus 2. Three to the y equals x minus 2. So the easiest thing to do on this is to graph this and graph this one to find the inverse. Verify the inverse. But I do want to mention, if our inverse is an exponential, just mark that out for a minute. Looks kind of ugly anyway. I think that I've got an error there and I'm too tired to go back through it for a minute. You definitely ask me in class, we'll go through that one. This is an exponential, is the inverse of a log. And if the exponential is the inverse, remember exponential functions, they go with the big curve. And our domain is all real numbers. And our range would have some limitation. It's going to be y is greater than, y is less than, something that way. Now for the log, since it's an inverse, we know that the domain will have limitation, but the range should have all real numbers. So that's what I would eliminate first with that. Okay, so we know that domain's going to have some limitation, range is going to be all real numbers. That's that option. This one's out. Ooh, this one looks like it's a possibility. And this one's out. Now the only difference here, this one has a domain that has limitation, this one doesn't. If we think back to our exponential, the y did have limitation. Being the inverse, that would mean the x has limitation. So this one can't be it because of that. Okay, so I guess we don't really have to go back to that. I would like to go back to it in class and have some fun with the graphing. It is kind of neat. Okay, now in this one, remember ln of x is the inverse of your natural log. It's the natural log inverse of e. So because we have the ln out front, we don't really need to worry about what it's all about, except for we need to make sure that we realize this is in expanded form, just like they did. They want to constrict. So they want to say this being multiplied, remember we multiply exponents when they're being raised to a power. So that would be a to the third. We bring this one back in now. When we're adding the exponents, it's when they're being multiplied. B to the second. Subtract means divide. C to the fourth. We could probably stop there and eliminate some things. Okay, definitely go to Unit 12 to see how this is done step by step. It's just a review for the test, how to eliminate. So this one, we can get rid of that. We can get rid of that. We can get, should look at the plus 5. Oh, the plus 5 would not be included in this grouping where it's got the E and the LEN. That is where those two come in handy, is knowing that those are inverses, they would cancel each other and you just have plus 5. So it's got to have that. We could have done that right at the beginning to eliminate. I'm sorry. So it's got to be that one. Again, go to Unit 12 if you need some help on that one. Down to this one, we need to solve this. That means we need to be able to plug it into a calculator. That means that in this situation we would go log 11, because we're converting it back. You can't just solve exponents unless you sit there and just keep punching it, and you wouldn't get it because it's not going to come out to a whole number. So you'd go same base, log 11 equals, log 11, base 11, 247 equals x. I'm sorry, I'm getting really tired. If I didn't have to get this on the YouTube, I would not be doing this. Okay, so here's our lower base one. We put that on the bottom, log 11. We put the other one up above, log 247, and that will be equal our x value. So we look for that one, and we find it right here. This is not correct. You don't want to be taking the log of those two being divided. And these, they're doing funky things. They're expanding when they shouldn't and that kind of thing. To solve it this way, we've done these in class. Okay, next one. We want to, first off, get this in usable format to solve it. So the very first thing that I would do is I would cancel everything by raising everything to the 7th power. I would cancel all those logs out. So that'll cancel there. And this, I probably should have put those together first. I'm gonna go ahead and do that. Again, when we have the logs, we're going back to our exponential expression. When we have the plus, it means the x times x plus 10 In other words, constrict it back down and you'd have the log 7. Now we raise it to the 7th. That'll cancel. And we have 2x plus 9 equals x parentheses x plus 10. So 2x plus 9 equals x times x plus 10. Now go ahead and work that on out. My battery is dying, so I'm racing the clock here. When you solve that, go ahead and solve it for x. You should get C. Next one, you're going to be plugging in. This is your starting and your ending. So your starting amount is 7,000. That goes in for P. We have E raised to 7% amount of time would be, okay, we're solving for T, so it's 0.07 T equals 7,700. You're trying to figure out how long you need to keep this money invested to earn it up to 7,700. So when you do this, you just go right ahead and you solve for T. Circle your T. Divide each side by 7,000. You'll end up with E 0.07 T equals 1.1. Now if we take ln, as we saw up above, it cancels with the E. So take ln on each side. And that cancels, and we find that 0.07 T equals ln of 1.1. Divide each side by 0.07. And we get T equals ln 1.1 over 0.07. You can actually plug that in your calculator and get the answer. You should get that T is approximately 1.36 years. Okay? If you don't have a graphing calculator at home, definitely come by and see me on this and practice with a graphing calculator. Next one, we're going to be plugging our x and y values. If this dies, plug your x and y values into the equation and solve it simultaneously using your systems that you know. So we'll go ahead and we'll start. This is your y, this is your x. So 12.5 equals AB to the second.